When you're just getting started with Spark and the APIs are really starting to click, it can be really exciting and rewarding as you get a lot of computational work done in just a little bit of code. But it's not exactly difficult to write suboptimal code by not paying attention to persistence. Now, we've covered elsewhere the idea of persisting or caching RDDs. This is also an important topic when it comes to streaming. If you look at this code here, you've got some kind of clickstream data coming in on movies. This is tracking user activity on particular movies shown on the Killer Video website. And we're using the reduce by key streaming transformation to count those things up. Easy enough. What do we do with that though? At that point then, we save it to Cassandra, and for good measure, we print it. Now that print is a little bit contrived, but think about it. Save to Cassandra and print, they're both output operations. That means they're going to trigger computation twice. And if you actually ran this code the way you see it here, you'd do the reducing twice too, and that would be a huge waste. DStream persistence is a way of giving Spark hints that it should persist particular DStreams either to memory or to disk. This way, a persisted DStream can be reused by multiple output operations without having to recompute it. So if you're going to call an output operation on the same DStream more than once, persistence is definitely something that should be on your mind. The API looks hauntingly like the caching API for RDDs. We've got a persist method that lets us specify a storage level, which really is a way of saying, do I want this to be persisted to disk or memory? And the cache method, which is what you're going to see most of the time, which is another way of saying that you want to call the persist method, specifying the memory-only serialized option. Now, when you're using a memory persistence level and something doesn't fit into memory, those partitions will get kicked. They will not be cached and they will be recomputed on the fly when needed. So in the broader context of optimizing a Spark application, you want to make sure that the nodes actually have the memory to do the persisting of the partitions you're asking them to persist. So this will affect the way you provision hardware, how much memory you pick for nodes, and the number of partitions you select for a given DStream or RDD. Again, most commonly you'll call cache, which is the equivalent of persisting with the memory-only serialized option. Now, memory-only serialized uses memory a little more efficiently than memory-only, but at the cost of higher CPU utilization. If I say memory and disk, then those partitions that don't fit in memory will spill to disk rather than being discarded altogether. And of course, I can opt to persist a DStream only to disk. Now, some kinds of DStreams are automatically persisted and you don't even have to call cache. Like any update state by key transformation is going to get cached. Any window transformations, those will be automatically persisted in memory. Remember that suboptimal code we saw at the beginning? The fix is really easy. All we have to do is call cache at the end of our window transformation. Then that DStream will be persisted to memory. And those two output operations that we call, save to Cassandra and print, are going to be called on the persisted in memory version, and the computation won't have to be run twice.